beauty. Okay, so ethanol can be made by reacting ethene with steam. Nice. In the presence of a catalyst. Now we've got diagrams galore. So we've got percentage yield, how it changes with pressure. Okie dokie. We've then got what happens to the rate at different temperatures and pressures. Okay, that looks fun. What we got to do in one process, for the reaction of ethene with steam, the conditions are right. Okay, bosh. Okay, gotcha. Use the information and your knowledge to justify this choice of conditions. Right. Okay. So what I would be tempted to do here is basically to break this down. So it's a 6-mark situation. We got temperature. So probably chatting about that is going to get you a couple of marks. We got pressure. Probably chatting about that is going to get you a couple of marks. Talking about the catalyst, I guess that might get you a mark. And then, of course, the whole point is that it's some kind of, we've got to justify, right? So the fact that this is all going to be probably some kind of compromise between various things. So let's just go one at a time. Temperature. Right, 300 degrees, eh? Let's have a look at the temperature situation. So, according to the graphs, when we're looking at the yield, 300 degrees looks excellent because it gives the highest yield. So basically, the lower the temperature, the higher the yield. Okay. What does it do to the rate? Well, let's have a look here. Temperature, what are we doing here? At 300, aren't we? So 300 is here. Okay, so the relative rate of reaction is looking like it's whatever that is, 1.6. All right. Okay, so if you're talking about temperature, I think it's probably worth identifying that the lower the temp, higher the yield. Okay, and obviously the higher the temp, the higher the rate. So we've already got that classic problem of, okay, do you want a lot of it or do you want it quickly? Come back to that. Pressure. What's going on with pressure? We're only at 65. So that's kind of down here somewhere, isn't it? Right, so pressure, sorry, down here somewhere. So that's not there, that's a terrible bit of maths. It's probably more like there. It would appear that actually pressure-wise, that actually this is not great. Maybe you want to run it at a higher pressure, and that would not be a surprise because, of course, higher the pressure should favour that forward reaction because there's less molecules on the right. However, the difference that it makes obviously is not significant. So I guess we just need to, I would make the point that higher pressure, gives higher yield. The other point, of course, is the rate. We'll probably even need to look at this, do we? But let's just clarify. There you go. Look. Higher the pressure. Oof, yes, definitely. Higher the rate. Okay. So what are they running? 60. Well, that's somewhere between these two, isn't it? All right. So notice at this kind of point, it starts to really make a difference. So it's probably also worth mentioning that the higher pressure, the higher the rate, or the faster the rate. This is just stats at the moment. We're just picking things off the graph, aren't we? And what do we know about a catalyst? Well, they haven't told us this, so it's probably worth mentioning that a catalyst, what it does. So that's obviously going to speed it up. The rate of reaction. Okay, so that's your kind of just fact-based stuff. Then we've got to get some kind of justification as to why that's going on. So I would suggest that the things that you want to be talking about are that basically why you're not running it even higher. So they were running it at 65, weren't they? and 300. So why wouldn't you run it higher than 65? So it makes sense to because it goes faster. Well, issues with high pressures. Well, one of the big things is high pressure. 2 issues with high pressure. You're going to have a high cost, and you're going to have a risk of explosion, because of course if you put things under pressure, there's going to be problems there. So that's one of the reasons why you're not running it any higher. The temperature, well, the temperature is going to have to be, the temperature is probably the best compromise, I'm using that word again, between rate and yield. Okay, so it's about making a statement that it's going to be the best compromise temperature. What about the catalyst? Why is that useful? Well, we said it speeds up the rate, but of course, why is it useful in the whole context? Well, catalyst is going to be able to reduce your energy costs, isn't it? That is a useful thing that you want to be writing as well. So all of that stuff is going to get you the marks. I know what some of you are like, so I will just chuck on the actual mark scheme for this one because you might not see where it's all come from. These are, remember, this is an exemplar one. Sorry, an exemplar. It's the one where they have like, these are possible examples of points. You could have made other things. I didn't really go into any of the equilibrium shifting or anything like that, and they haven't here either. And if you actually read the question, I wouldn't be at all surprised if a lot of you have chatted about equilibriums moving to the right and left and all that. It does not ask you to explain why changing any of these things affects the yields. All it says is use information, which we did, and your knowledge to justify the choice. All right, so just be careful that you don't actually go do more science than you actually need to do. So here's that. Let's just pop it up there. Where are we? Temperature, pressure, compromise. That's what it says. Feel free to pause it if you want. We're done.